In today's lesson, we're once again adding more audio to the main mechanic of our game, the firing of the tank shells. The plan is to first play a charging sound whilst the player holds down their fire button and charges their attack. Following this, we're also going to look at not only adding an echo effect to this sound in real time, but also modulating it so it grows with intensity the longer the player's attack is held for. This lesson will combine a lot of previously discussed concepts as well as introduce us more to how we can interact with the many audio effect components that Unity has on offer for us from within a C# script. Now let's start by implementing that charge sound. In your audio clips folder, you should have a file called shot charging. This is the sound we're going to be implementing, so give it a quick test play in the inspector tab to familiarize yourself with it. Now, as we already know, the person playing our game is able to either fire the cannon on their tank immediately by pressing the fire button once, or they can hold the button to power up their cannon so that the shell fired does more damage. They can't hold the fire button down forever, as there is a limit to how long they can charge it for. If the limit is reached, then the shell will fire. So we're going to want this sound to play the moment the player presses the fire button. As soon as the shot is fired, either as the player releases the charge prematurely, or once the charge limit has been reached, we'll want the sound to stop. The player should then hear the sound of the shell firing, which we implemented already back in the first lesson of Module 3. Okay, so that helps us understand the mechanics better. Now, in order to start implementing this sound, we need to open the script responsible for controlling the charge mechanic, which is the tank shooting script that we've edited before, attached to our tanks. So inside of our project tab, we're going to find our tank prefabs once again by opening tanks, completed assets, prefabs, and finally the complete tank prefab. Once there, find the tank shooting script in the inspector tab and open it up. Okay, here we are back in the tank shooting script. The first thing we're going to need in order to play our shot charging clip is a reference to the clip itself. So let's first create a public audio clip variable, and to distinguish this audio clip variable from the array of clips we created in Module 3, we'll call this one shot charging clip. Later on, we'll go back into Unity and assign the clip to this variable in the Inspector tab. Now, in order to play this clip when our player first presses the fire button, we'll need to detect when the button is being pressed. Thankfully, our script already has code written within it that checks every frame to see if the player is holding down the fire button. This code can be found inside of the update function. Specifically, it can be found within the first if statement and the following three else if statements. Now, there are a few things that tell us that these statements are what control how and when the shells are fired. The first and most obvious is thanks to the programmer notes above each statement written by the developers of this script and the tanks game. For example, the note above the first if statement reads, if the max force has been exceeded and the shell hasn't yet been launched, ... Whilst the next note inside the body of the if statement reads, use the max force and launch the shell. So we now know that the condition of the if statement checks to see if the current launch force of the shell is ever equal to or greater than the max launch force variable, and if the fired Boolean variable is false. Then if this condition is true, the current force is set to the max force limit, just in case it exceeds it, and then the fire function is triggered. The fire function we're already familiar with, as we've used it to play our shell firing sounds once a shell is fired. So that's the first indicator that these statements are what are checking to see if the shell can be fired. However, we're not just after when the shell is being fired. We want to find the moment before that, the moment when the player presses the button that then fires the shell. Well, if we take a look at the condition of the first else if statement, we get our second clue that we're in the right place. The condition is checking the result of a function called getButtonDown. Now, what is this getButtonDown function and how does it work? Well, like the log and range functions, getButtonDown is another function created by the developers of Unity. Just like how log belongs to the debug class and range belongs to the random class, getButtonDown belongs to the input class. So when calling it, we must write input.getButtonDown. This function is used to check one of the buttons on either our player's keyboard or controller and see if it was pressed on the frame that we called it on. If it was pressed, then it returns the true value, and if it wasn't, it returns the false value. If paired with an if statement, you can then tell your script to do something immediately in response to this player input, such as play a sound effect. To tell it which button you wish to check for, you simply write the name of your button as a string inside the parameter brackets of the function. Now, Unity has a whole system called the Input Manager that allows you to name each individual button with a string. To access the Input Manager in Unity, go to Edit, Project Settings, Input Manager, Axes, and then select an access to edit. If we look at Fire 1, we can see that the string needed to activate and check this axis would be Fire 1. So we'd write that inside of our Get Button Down function. By doing this, we'd be checking to see if the space button is ever pressed by the player, which, as we know, tells the blue tank to fire. Likewise, if we open Fire 2, we can see that by writing Fire 2 as a string, we'd be checking for the Enter button, which tells the red tank to fire. Now, when creating a game, you can edit the Input Manager and the names used to recognize each button in your scripts however you like, but for our purposes, we can leave the Input Manager as it is. Going back to the else if statement inside of our script, it now makes a bit more sense. After the if statement above has checked for its condition and found it to be false, this else if statement will check to see if a specific button has been pressed on this frame. Whilst there is no string being passed into the function, we can see a string variable is passing in string data, representing a button, presumably one of the fire buttons we looked at. In fact, if we scroll up to the start function quickly, we can see that this very variable is being told to hold the word fire, as well as a number for each player. So this would mean that the variable would either be holding the name Fire1 or Fire2, the names given to the space and enter buttons in the Input Manager. So we can now say with confidence that this else if statement is where we'll need to tell our charging shot sound to play. Of course, if you're ever unsure about the purpose of a function or a statement in a script, you can also add the debug.log function to it and test to see if it triggers and behaves in the way that you expect. So to tell our sound to play, we'll be using the audio source component that we reference inside of the source variable we declared inside of this script back in module 3. We'll first need to give that audio source the shot charging clip we want to play. So we'll write source.clip is equal to shot charging clip. And then to play it, we'll simply use the audio source's play function. Excellent, we now have a way to play our sound whenever a player tries to fire a shell. Before we move on, let's save our script and see how it sounds in game. Before we play the game itself, don't forget that we need to assign our clip to our new charging shot variable. So in the Inspector tab, we will quickly do that now. Great, let's then save our prefab and play the game. Okay, so let's hold down either the space or enter key and see if we hear our sound. Excellent, we do indeed. But now let's see what happens if we simply press one of them. Okay, so we heard the sound play, but really we should hear it stop once the shell is fired. So let's end our test there and jump back into our script. Okay, so in order to tell our sound to stop, we need to know where in our script we'll execute the command. Essentially, what's going to trigger the stopping of our sound. Well, you may have noticed that the two other else if statements below also use other similar functions that belong to the input class. The first function is called getButton. GetButton is similar to getButtonDown. The difference is that getButton returns a value of true on every frame that it detects that the button you're checking for is being pressed, instead of the first frame. Essentially, it checks to see if a button is being held. Now, you may think that because of this, we should be using the getButton function instead to tell our sound to play. However, if we were to tell our sound to play here, our sound would be told to play from the very beginning on every frame that the button was held for. for. Imagine pressing play on your favourite music playlist 60 times a second. You wouldn't be giving the music a chance to play. Instead, it would constantly be resetting. We only want the sound to play once, so get button down works much better for us. Get button up then is essentially the opposite of get button down. It returns true on the frame that the player lets go of or releases the button we're checking for. This might make it a good option for telling our sound to stop. However, let's remember back to the beginning of this lesson where we walked ourselves through our plan for the charging sound and the mechanics behind it. We want it to stop when either the player releases the button they were using to charge their shot, or the shot's power has reached its maximum and the shell is fired. The player could theoretically still be holding the button at this point, but the shell would have already been launched, thus we need the charge sound to stop. So whilst this else if statement using the get button up function would trigger when the player releases the button, it wouldn't if the shell was launched after reaching its max force. Remember that the very first if statement in our update function was what checks for this condition and triggers the fire function if it is true. So this leaves us with two options. Either we tell the sound to stop in two places inside of our script, which we could do and our sound should stop perfectly fine, or seeing as both statements trigger the fire function and launch a shell, we may as well tell our sound to stop inside the fire function. This way we only need to write our new code in one place in our script instead of two. So we'll do that. Let's scroll down to the fire function, which we've looked at a bit before. Now inside of this function, we've previously written code to randomly select a clip from our clips array and play it. We'll then tell our charging shot clip to stop just before any of this happens. So before we declare and set the new index integer, we'll tell the audio source to stop playing our sound by using the stop function. Simply write the name of the audio source, which is source, followed by .stop with a capital S. And that's it. The sound will now be told to stop when the shell is fired. Let's save again and make sure this is what happens inside of the game. Okay, so this time, if we fire a shell quickly, we shouldn't hear the charged shot sound play, if only slightly. And if we hold one of the fire buttons, we still hear the charge shot sound perfectly. Great! It doesn't matter if we hold down the fire button until we're fully charged or release it prematurely, we hear the sound stop regardless. Brilliant, so now that we have our charge shot implemented, it's time to look at adding our echo or delay effect to our sound. Now we already know how to add an effect to a sound, and thankfully it's pretty easy. Let's go back to the prefab of our tank. Once there, let's scroll to the bottom of the inspector tab and select add component. Then we'll search for audio echo filter and then select it. And it's as simple as that. We can now save our prefab and see how it sounds in the game. Okay, here we go. Okay, so at the moment, the delay or gap in between each echo is quite long and obvious to us. We're also hearing the same delay on the sound of the shell being launched too, as both sounds are using the same audio source, and thus the filter is affecting them both. Now our goal is to modulate our filter so that it fades gradually the longer the charge is held for, in a similar way to how we faded our music in at the beginning of this module. Not only that, but once the shell is fired, we want to remove the echo so that it is not added to the following shell launching sound. So let's end the game there and start by making a few tweaks to the audio echo filter component itself. The first change we're going to make is we're going to start the wet mix at 0. As I'm sure you're familiar with, in the same way that a delay plugin would work inside of a DAW, the dry field controls the level of the original signal that isn't being delayed, and the wet mix controls the level or signal that follows, where we hear the same sound repeated. Now, seeing as we want the effect to fade in gradually from nothing, we'll start wet mix at 0, and then use our script to tell it to rise up to 1 when needed. The second change is more of a personal aesthetic or design choice. I'm going to set the rate of the delay to about 200 milliseconds, just so that the gaps in between each delay aren't too long. Of course, you may prefer longer gaps, in which case you can leave this field or change it however you wish. I'll also include a link underneath this lesson to the Unity documentation, where you can read about each field we have here on the echo filter, as well as other audio-based components. So now that our echo filter is set, let's jump back into our script and look at modulating it. Okay, so the first thing we need is to get and reference our new echo. So underneath where we created our last audio clip variable, we'll create a private audio echo filter reference variable and call it echo. Next, inside of the start function, underneath where we got our audio source component, let's get our echo filter by writing echo equals get component audio echo filter. Great, we now have access to the component. Next we need to modulate the wet mix field over time. Remember that we want this to happen whilst the player is holding the fire button. So that every frame that the button is held for, we can increase it ever so slightly. Now earlier we looked inside of the update function and found that one of the else if statements was checking for this exact situation using the input.getButton function. So make your way to that statement, and once you've found it, make sure you're looking at the right one. Remember, last time we used the input.getButtonDown function, but this time we want the getButton function, as it returns true, and therefore will execute the statement on every frame that the button is held for, as opposed to only the first frame. The last time we modulated a variable in the music fades lesson, we looked at coroutines and how they are better for our game's performance than the update function when it comes to making increments over time. So whilst I would normally recommend that you create a coroutine function to calculate your modulation with, and then trigger that function in the same place as where we told our sound to play, in order to demonstrate and familiarize ourselves more with the getButton function, as opposed to the getButtonDown function, we'll be using this else if statement instead. Now to increment and modulate the wet mix, we first need to access it. To do that, we will write the name of the variable referring to our component, which is echo. Then, as we know, to access public variables and fields within a class or a reference component, we follow the name of it with the dot operator, followed by its name, which is wet mix. Okay, so from here, how do we modulate the wet mix level whilst the player holds the fire button? Well, let's take a look at this formula. I call it the time modulation formula, and we can use it to help us calculate by how much we need to increment or change any variable by each frame to modulate it over time. So it works like this. The change in the variable's value per frame is equal to time per frame divided by the total length of time multiplied by the difference in range. In the music fades lesson, we used this formula. We incremented the volume of our audio source each frame by taking time.delta time, dividing it by our fade in time, or the total amount of time we wanted our fade to last, and then multiplied by the difference between where we wanted the volume to start and end at. So let's do the same with our echo's wet mix level. The wet mix is what we're modulating, so it sits at the front of the formula. Then we take time.delta time and divide it by the total time our shot will be charged for. There's actually a variable in the tank shooting script called m_max charge time that represents this time, so we'll be using that here. Finally, we multiply the result by the difference in range of our wet mix. Now, the wet mix field of the audio echo filter ranges from 0 to 1. The difference there is obviously 1, and any number multiplied by 1 doesn't change it. So we don't need to include anything after we've divided time.delta time by the max time variable. And that's all we need to do to modulate the wet mix. So let's jump back into the script and make some changes. So next to where we access the wet mix, we'll write plus equals to increment the value each frame. We'll then follow our formula and write time.delta time divided by the total time, which will be represented by m_max charge time. Perfect. Now there's one final thing left for us to do. Once the player has finished charging their shot and the shell has been fired, we no longer want to hear any echo through our audio source, as we don't want any on our shell firing clips. So let's scroll back down to the fire function. In the same place we told our audio source to stop playing the charging shot clip, and right before it plays one of our shell firing clips, we're going to reset the wet mix back to 0. So let's write echo.wet mix is equal to 0. And that's it, we're all set. So let's save our script and take a listen to our modulated echo effect. If you haven't already, don't forget to save your prefab before testing the game. Okay, let's start by charging a few shots fully. Great, so not only do we hear the echo build gradually towards the end of the charge, but once fired, there's no more echo heard on the actual shot. Let's then fire a few shells with little to no charge on them. Because the shot isn't being charged fully, there's not enough time for our echo to be heard, which is exactly what we want. And there we go, we've not only implemented our charge shot sound, but we've learned how to detect direct button input from the player, how to tell our audio to stop, how to access one of Unity's filter components, and then modulate it as our audio plays. So that's quite a lot to cover over one lesson. Hopefully you were able to follow along with everything we covered today. You may have gotten a little lost or weren't quite 100% sure of why things worked the way they did in some places of that lesson. For example, during the parts where we looked at the many different if and else if statements and were able to work out that they were how we could detect when our player holds the right button or our shells are fired. If that's the case, I'd say don't be afraid to go through the update function and just add the debug.log function to the various statements with various messages inside and see when they pop up in the console tab of Unity. It's such a helpful way of understanding the logic behind a script you're not entirely familiar with. Of course, we do have a few different debug.log functions in our scripts that might now be clogging up your console tab with old messages we don't need anymore. So feel free to go back to older scripts and remove them if they no longer benefit you. But anyway, we'll be looking more at real-time effects in Unity as we continue, so I hope you found this introduction to them helpful. Once you feel ready, head on over to the next lesson.